All right, today we're going to do some compound interest calculations. We're going to take some questions, apply the formula that we learned in a previous video, and see how we go. So Cherie, she's got $15,000. She invests it in an account. That account earns 4% per annum compound interest. Now, if the question doesn't say compound interest, just assume that it's simple interest. But if it says compound, then yeah, it's compound interest question. So after 5 years, calculate how much she has in the account and how much interest she earned. All right, let's have a look at how we do this. Here's our compound interest formula. Hopefully you remember what each of these letters represent. A is the amount that the investment or the loan will get to. It's what it ends up being. P is the principal. It's the starting amount. R is the interest rate, always as a decimal. Don't use the percentage. Convert it to a decimal by dividing it by 100. And N is the number of time periods. So in our question, the A is the bit we don't know. How much she has, how much the amount that it grows to. That's what we're going to work out. The P, the principal, it's $15,000. That's what the starting amount was. The R, the rate, is 4%, but you'll see down here I've got it written as a 0.04. Always use the decimal version. And N is the number of time periods, so 5 years. Now I've got values for P, R, and N. All I do is I come over to my formula and I just substitute those values in. So replace the P with 15,000, the R with the 0.04, the N with the 5. Whack that in your calculator and you'll get this amount. So after 5 years, that 15,000 grew to 18,249.79. Question B was how much interest has she earned? The amount was just is simply the principal, the starting amount, and everything else is interest. So she put the 15,000 in. All the rest represents the interest. So the amount is made up of the principal plus the interest. So I can put those figures in. I know the amount that it grew to. I know the principal, and it's just the difference between the two. But if you want to do pure algebra here, basically what we did was to solve for I subtracted 15,000 from both sides. So the difference between those two figures was the interest, 329.49.79. Well done. Let's have a look at one that's a slightly different thing. Hopefully you're going to see the twist here before we get too far into the question. Jacob took out a loan. Now, compound interest can apply to loans as well as investments. It's the same idea. One is where you're getting money. One is where someone else is getting your money. He took out a loan for 10 years, compounded annually. So it's compound question at 6% per annum. If he has to pay back this amount, so this is the final amount that this loan has grown to, how much did he borrow? So what was the principal? So I don't know the principal in this question. Okay, I don't know the starting amount. I know the amount that it grew to. So first, before we play with this formula, let's just have a look what we do have. We've got the amount that the loan grew to, the A value. We've got an interest rate of 0.06. Remember to turn that into a decimal. And the time periods are 10 years. Now, what I don't have is the P, the principal. How can I use this formula to work out P? Well, this is where your algebra skills come in. We are going to rearrange this to make P the subject of the equation. I'm going to do it traditionally, and then I'm going to show you a little visual trick that you can use if you'd like to. So looking at this, I've got P times all of this piece. So the opposite of timesing this piece is dividing by this piece. Whatever I do to one side, I have to do to the other. That way, the common factors here, these bits can cancel out. So all I'm left with on the left-hand side is the P, and on the right-hand side, I've got this. So my equation, I've rearranged it to make P the subject of the equation. Now, if your algebra skills are a bit rusty, have a bit of a practice, or you can try this little trick. Basically, all I did, just off to the side here, all I did was I took this piece, all the bit that wasn't the P, and I dragged it underneath the A on the other side, and I end up with this exact same formula. So it's just a little bit of a visual shortcut. You can use whatever, but this is now what we need because we're trying to work out the principal. I've got values for A, R, and N. I just plug them all in to my equation, whack that in the calculator, and I get a value of 18,000. So initially, at the start of the loan, he borrowed 18,000. Over the 10 years, it grew to that 32,000 odd. So there's two examples of how we can use compound interest either to find the amount that something's grown to or the starting amount if we're given the final amount. Good job, well done.